Welcome to lecture number 41, the new chapter called Standard Template Library. Often it is called STL. So, again, I am coming back to C++, right. So, now you are more familiar with C++ and Java, and in the last one or two lectures, I talked about Python. So, my advice is you start using Python as well, alright. So, when I am explaining about standard template library, again I am switching back to, let us say, C++, right. So, in fact, STL is nothing but the collection of C++ template classes and functions, right. So, we extensively talked about the template classes in the last chapter, right. So, here STL, which is nothing but the collection of C++ template classes and functions. So, in fact, it provides the data structures, right. Suppose you want to store the data, right. So, there are several ways. So, one particular data structures that you have studied is list or arrays, two-dimensional arrays, right. Advanced version, when we go, so you have a linked list, doubly linked list, binary tree. So, these are all the data structures. So, STL provides these data structures. So, you call it as containers, the inbuilt, right. So, not only the data structures, and you have the algorithm, some of the algorithms, all right. So, that means, so because of data structures and algorithms, so this STL, which is facilitating efficient and reusable code. So, STL, which is built on three major components, right, which are nothing but containers, iterators and algorithms. Also, so when you are having a STL, so basically it is defined to offer a standardized and extensible framework, right, for managing a data and performing the operations on it, right. So, these are all some of the characteristic features of this STL, standard template library. So, what are all the advantages? So, we can have code reusability, since you know templates, all right, and then we have talked about the templates functions and template classes. So, the STL, we have the code reusability, that means we can use it for any data types, and performance is highly optimized because it can use many inbuilt functions, all right. So, therefore, it is highly optimized, and you no need to manually implement certain algorithms, right, certain operations. So, performance point of view, STL is having advantage, and consistency, right. So, since it is offering a unified framework, this is ensuring the consistency in the interfaces across containers and algorithms. Extensible, so you can extend the algorithm, right. For example, assume that you have insertion algorithm in one of the data structures. So, based on this insertion algorithm, I can use this, right, as a module. Can I extend? Yes, you can do this, right. So, that option is available. This is added advantage, right. So, the extensibility and reduce development time, since you can use many data structures and algorithms readily available, right. So, which is already available. So, that means the, I mean, you no need to develop anything new, for example, the standard algorithms or standard data structures, right. So, this is reducing the development time. So, these are all some of the advantages, and as I said, the three major components, the containers, iterators and algorithms, right. So, the containers, suppose I use vector, list, right, set and map, right. So, that means the containers, which is nothing but store and managing the collection of data, right. So, which you can do it very efficiently, that is called containers. So, vector is a container, list is a container, set is a container and map is a container, right. So, these are all the examples of the containers. Similarly, you have iterators, begin, end, or begin, or end. So, that means it is providing an abstract interface, right, for you can traverse all the elements in the containers. For example, you are given a vector, you can traverse vector 0 to vector n minus 1, or list or set, right. So, you can traverse which is the begin, which is the end, right, because sooner or later we are going to talk about some data structures. Let us say doubly ended queue, right, which is front, which is the back, right, or end, which is the end, right, begin and end, correct. So, that is nothing but the iterators, right, and algorithms. So, several inbuilt, for example, I have an algorithm for searching, given a data structure, I want to search an element, or given a list, I want to do the sorting, right, sorting in ascending order or sorting in descending order, or I have to update the data or modify the data. So these operations are already, right, several inbuilt functions are there in STL. All right. Suppose you are working as a developer. All right. So assume that you don't want to know the deeper of the algorithm, but you want to use, right. I want to, let us say, sorting. I want to use sorting algorithm, right. So there are several actual data structure. When you study, you have several, right, algorithms and you have to implement. But here what you can do, you can call sort, right, the sort function that you are calling, and then it will do the sorting. You can see how you are going to sort, whether it is an increasing order or decreasing order, it's available. Or finding, right, finding the elements in the list, or finding the elements in the vector, all right, or transform, you are transforming into some other data, modifying the data. So these are all possible. So that means the three that we are seeing in this particular slide, they are the major components of STL: containers, iterators, and algorithms. So in fact, we had talked about containers in Python also, if you recall, right. There we talked about the instances, right. So here in the C++, it is nothing but the objects. Containers are nothing but the objects, right. So the objects which are storing the collection of data. If I take an array object, right, int a of 10, that means it is storing a0 to a9, all right. So it is storing the collection of data. So in a similar way, the containers, they are nothing but the objects that is storing the collection of data. And here when I am talking about STL containers, so this provide the various range of data structures, right. So starting from the dynamic arrays to hash tables, right. So STL containers, you have various levels of data structures, right. So it is providing, right. So dynamic array to hash table, so we can see in STL containers. So if I am talking about the container, so every container type, so which is useful or which is designed for the specific use cases, right. So this is balancing the trade-off between the memory usage, and then suppose you are doing some algorithms like insertion, deletion, and traversal speed, right. So you have the memory usage, and then assume that I am using one of the algorithms or all the algorithms, insertion, deletion, right, and traversal speed. So it will balance the trade-off between memory usage and the dictionary operations like insertion, deletion, or traversing, right. So containers are nothing but the foundations of STL, so which is enabling the efficient data manipulation and the management, right. So efficient data management and manipulation. So what are containers in STL, right. So as we have already seen, it is nothing but a data structure that stores and organizing a collection of objects, right. So which is a standard definition. So now when I am talking about the generic, right, we have used in the last chapter, we have used the generic concept, right. So STL provides the generic containers. Now you know the meaning of generic, right. So this can work with any data type, all right. So generic in Java, generic in Python we had seen. So that means this STL is providing generic containers. So that means it can work with any data type, all right. Also containers manage memory allocation and deallocation, all right. So these things will happen internally. So that means the program will be simplified. So when you are having allocation and deallocation, so you are safe with the memory management. And these are all the broad categories, right, the containers. So you have sequence containers, associative containers, and unordered containers, right. So these are being categorized based on the structure and functionality. So what do you mean by sequence containers? So in the previous slide we had seen, so explanation for this. So when I am talking about vector, right, or list or deck, doubly ended queue, right. So these are all the sequence containers. That means you can take list or an array, right. So they are in the contiguous memory location. That means the linear ordering, right. So they are all in the linear ordering, vector, list, or doubly ended queue, or simply queue, linked list, right. So these are all linear order. So you call it as sequence containers. Associative containers, right. So if I take certain maps, so it may store the elements in some sorted fashion, and it is also having the keys, right. So the keys you can retrieve fast, right. So the examples are set and map. So it stores the elements, So, even if it is storing in any form, you are having keys. So, with the help of keys, you can retrieve it, right. So, you will find out in a sorted fashion set and map, and they are all using keys, right, for retrieving the elements quickly. Unordered containers, right. So, in the case of unordered containers means any fashion, the elements are right in any fashion, that means it was not sorted, you call it as unsorted, right, and then it uses this unordered containers uses hash tables, right. So, this unordered container, so they are using hash tables, right. So, since the elements are in unsorted fashion, so when you want to retrieve, right, you use hash table. So, that means you can, if you want to retrieve the elements, so you can do it fast. So, what are all the examples? You have unordered underscore set and unordered underscore map. So, if you simply use set and map, they are ordered, whereas here in this case they are unordered. So, like this we can define, we can categorize the containers, sequence containers, associative containers, and then you have unordered containers. So, as we had seen in the case of sequence containers, right, and the elements are arranged in a linear fashion. So, that means obviously some of the basic dictionary operations like insertion, deletion and traversal can be performed very easily, right. So, in fact, you have the operations, alright. So, these containers have the inbuilt operations. So, for example, I have a common sequence container such as a vector, right. Vector is a dynamic array, list is, let us say, doubly linked list, and doubly ended queue you call it as a deck, right. So, these are all some common sequence containers. So, already inbuilt functions are there. So, that suppose I want to have some operations like dictionary operations like insertion, deletion, updation, right, all these operations I can perform very easily, right. So, in fact, when you want to manage the collections of data, right, so the sequence containers are very ideal, right. So, because you have a sequential access. So, for example, I want to search an element, right. So, sequential search. So, starting from 0 to n minus 1. Yes, time complexity we will worry later, but you can move around from 0 to n minus 1, right. So, it is ideal because the elements are arranged in a linear fashion. The sequence containers are ideal for managing collections of data, right. So, because of the nature, right, the sequential nature. The next one is a vector, which is a dynamic array, right. So, dynamic array, we know that you can resize the number of elements in the array. Assume that first time we are using for 100 elements to sort, and then same array name we are going to sort for 50 elements, or we are going to use it for searching, right. So, you call this as a vector, which is a dynamic array. So, that means it supports the random access, and this is allowing efficient insertion and deletion at the end, alright. So, you can do the insertion, the basic dictionary operations, and in fact, the key operations that you can do over here, push underscore back, that means you are adding an element at the end, alright, adding an element to the end. Pop back, so remove the last element, right. Suppose I have 10, 20, 30, right, I use push back, let us say 40 is a function, I am inserting an element 40, right. So, that will add over here 40, right, and assume that one more time I am calling push back by passing 50, I will insert. Now, pop back, so remove, this will be removed, pop back. Size, the size will return the number of elements, right. So, right now number of elements is 4, 50 have been removed, right. So, this will return the number of elements in this particular vector, and at is nothing but the access an element by index. So, 0th index is 10, first index is 20, right, at of 4, in fact at of 4 is at of 3, 40, right. So, that means when you want to access an element by index, so you can do this, alright. So, suppose you are writing a program where you have to insert lot of elements, right. So, in that case it is advisable to use the vector, which is nothing but the dynamic array. So, now we will see an example. In fact, we can run the code also, because the last few classes we are talking about the Python and Java, right. So, we will again maybe this particular code we can run. So, let us see what is happening, alright, in this case. So, here first time we are using the keyword called vector, right. So, vector in STL. So, what you have to do? You have to include vector, hash include vector. So, let us see what are all the usage. Int main. So, here you have vector is a class, it is in fact having the integer, correct. So, the array which will be having integers, a dynamic array, the dynamic array of integers, that is the meaning over here. And then you are using the name of the vector is numbers, right, name of the vector is numbers. So, what you are doing? Numbers push underscore back. So, first I will put 10, right. So, push underscore back, first I will put 10, right. Again I am calling, members is calling, sorry, numbers is calling, push underscore back, right. You are pushing another element 20. Numbers dot push underscore back, you are entering another element which is 30, right. So, now 10, 20, 30. Going to line number 13, for int I is equal to 0, I less than numbers dot size. We are calling the function, size function, all right. So, 1, 2, 3. So, in fact, it is 3. So, that means for I is equal to 0, I less than 3, I plus plus or plus plus I, all right. So, C out element at index I, all right. So, element at index I. So, I is 0, it is printing I, that means 0th index. Numbers at I, you are using another function. So, what are all the functions you are using? Under vector, push underscore back, line number 8, line number 9 and 10. And line number 13, your size, numbers dot size. And line number 14, you are using at, all right. So, here numbers at I 0, numbers at 0 is what? 10. So, the first output we have to get 10. Again, when I becomes 1, numbers at 1 is nothing but 20 and numbers at 2, what is that? 30, all right. So, when you are pushing these 3 elements, this is output, I will just put OP, OP is nothing but output, all right. So, up to here over std endl, so up to here it is over. Now, line number 18, numbers dot pop back, all right, the end you have to pop. So, end of the element is 30, this has to be popped, going out, that is the meaning of pop, right, deletion. So, what will be the remaining? 10 and 20, the remaining will be 10 and 20. So, now when the remaining is 10 and 20, what is the size? I am printing numbers dot size, right. How many elements? 2 elements are there, 2 should be printed. So, these are all the output we will get. So, in fact, when we run the code, so we are getting 10, 20, 30 and 2, right. So, let us see in the C++ prompt how this is working. Let us go to the compiler. This is what I explained, right. So, when we run the code, compile and run, yes, you can see the output over here, right. So, 10, 20, 30 we got, and then when you put the pop back, 30 will be out, and the number of elements, once 30 is out, we are getting the output 2, okay. I hope it is clear now. List, right, the next vector we had seen, list. So, list is nothing but the doubly linked list, right. So, doubly linked list, what it is happening, the structure will be, node will be like this. It may have some value and then there are 2 pointers. One pointer is pointing to the forward direction, another one is the backward direction, right. So, this will have, let us say 20, right, and then this may point out over here, right, and then maybe forward. So, that means one link is forward, another one is backward, right. So, you will have a data and then the pointers. So, one pointer is pointing towards in, another pointer is going out, all right. So, this is happening in the 2 directions. So, usually a singly linked list will be like this 10 and then the link will be like this, only one direction, pointer will be pointing to one direction. So, whereas here you have the next as well as previous. So, you have the information, you have the pointer, just point to the next node as well as the previous node. So, here if you have a next node will point here, all right, whereas the previous node is pointing 10, let us say another node I have 30, all right. So, 20 pointing over here, that is the meaning. So, you have one pointer is pointing to the next, another one is the previous. So, that means you will have the efficient insertion and deletion because you have 2 pointers, better than singly linked list. So, you have the advantage, and moreover here you have several inbuilt functions, right. So, that means it is supporting efficient insertion and deletion at both the ends. right, or in the middle. So, the main operations here you have push front, push back, pop front and pop back, right. So, these are all almost similar one we had seen vector, right, but here you have the advantage of two pointers. One pointer is pointing towards the forward, another one is backward or the previous next, right. So, that means push underscore front, it is adding the element to the beginning. So, suppose I have the W linked list like this 10, 20, right, and then it is going forward and 1 will be approaching here, right. So, what will happen? I mean adds an element to the beginning, right. So, that means this pointer will take over and 5 will be added, right, and then it will have a pointer towards 10. Initially it starts from 10. So, when I put push front, 5 will be added like this, or you can add push back 25 I want to add, alright, I want to add let us say 25. So, I can add it here, that is what push back. So, one pointer is going here, another pointer will go here. Alright, pop front. So, pop front is nothing but I will delete the front one, pop front, right. So, deletion of this node, that is pop front, and pop back I will delete this node, right. So, these functions in fact these are the inbuilt functions. So, in fact if you study the separate course called data structures, you will have a W linked list. So, you have to write all the code, right. Whereas, in the case of STL all these you are having added advantage. So, that means the inbuilt function is there, right. At one point of time you know it is advisable you have to write the code, because when alright, when you are developing an algorithm you may have to do the efficient algorithm, right. So, all these concepts you will study in data structures, right. So, right now we are enjoying with these functions. So, because these are all available and I can call. So, once I define let us say W linked list, I can have what is meant by push front, what is meant by push back, I simply call. So, I have told you what exactly it is happening, right. So, these are all the key operations that you can find in the list and you call it as a doubly linked list, right. So, let us consider this program, alright. So, you have include IO stream, first time I am including list, okay. So, the list of integers, so let us give a name as numbers, alright. So, list followed by the angle brackets, put int inside. Now, the numbers push back, initially it is empty, the W linked list is empty, alright. So, push back 10, so first it is 10, right, it will be like this, correct. So, next push back 20, alright. So, 20 push back, so 20 will be like this, maybe null, here it is null 20, right, and then push front, so 5 will be here. This is what the meaning of line number 8, 9 and 10. Yeah, of course, the pointer will go. So, right now here it is understood that this point is pointing to null, right, this pointer, and similarly this pointer is pointing to null, okay. Here it may be P and here it may be Q, because one pointer should point to the previous, right, another one is the other way around. For example, here I put both in the same direction, P should be like this, right, it is called the right pointer and Q is the left pointer. And here once it is like after push front, this will be obviously pointing to null and this will be pointing to null. So, in fact, the course called data structures you will study all this. So, right now we are utilizing all inbuilt functions. So, when we are calling this, so this is happening. Right now the data structure is like this. So, now for int num, right, numbers is a list mapping into num, that means both the base addresses are pointing to the same location. So, now C out num, right. So, that means it is printing all the numbers. For example, here in this case it will print 5, 10, 20, right. So, it will print 5, 10, 20, alright, and then C out, it is just a dummy statement, C out, nothing will happen, maybe a new line kind of, and then pop front, right. So, when I do pop front, I am removing 5, let us say 5, 10, 20. So, here I can use it. So, pop front meaning is I am removing 5, pop front, right. Now, the remaining array is 10 and 20 and then pop back, line number 19 you have pop back. So, that means this will also be popped out. What is remaining? 10, right. So, the remaining 10, correct. So, that I am going to print num, correct. So, when I run the code, I will get the output 5, 10 and 20, correct. I got 5, 10 and 20 and here pop out the remaining will be 10, right. So, that will also be getting printed, right. So, this is all about your list. So, when I run the code, I will get 5, 10, 20 and 10. In fact, it is a doubly linked list, right. So, this is called doubly linked list. So, this is all about list, and in the next lecture, we will talk about the doubly ended queue. You call it as DEQ. Okay. So, from here, I will start in the next lecture. Thank you all.